Let's take a look at sample AP multiple choice number 15, which is about the reaction between magnesium, a 0.10 gram sample of it, and excess HCl of differing concentrations. Now, the question's asking me to figure out what's the relationship between the reaction time and the rate. And just to help me out, I'm just going to sketch out the least concentrated HCl, which is the 0.05 mole per liter sample, with the most concentrated one, which is the 0.50 mole per liter sample. Okay, so I'm going to react the magnesium in this test tube, and this is going to produce product. That's fine. However, the most concentrated HCl, this is going to be much faster because there's going to be more collisions between HCl and magnesium just because you have more HCl to react. So I know this one's going to be faster. So if it's faster, then the reaction time, the time is low. Okay, so we're going to have a small number for the time. The least concentrated HCl, this one's going to be the slowest because it is, you don't have as many HCl molecules because of the low concentration. So again, there's going to be less collisions between HCl and Mg over here. So because this is a slow reaction, the time it takes for this to occur is going to be a big number. This is going to take time. Sorry, let me fix that. So this is going to take more time, and so time will be a bigger number. Okay, so that's the time component. What about the rate? So if you guys remember, the definition of rate is the change in quantity over the change in time. Now the quantity, I'm going to write the rate equation twice, one for my less concentrated reaction and once for my more concentrated HCl. Change in quantity over change in time. Hopefully you can read that. So the quantity here, if we focus on the Mg, that's my limiting reactant, it was 0.10 grams. And now the time, I don't have a real number, so I just kind of used an arrow to show that in the less concentrated one, time will be a big number. So I'm going to have a large denominator in the slow reaction. In the fast reaction, the time decreased, and so I'm going to have a smaller denominator in the fast reaction. So if we think about this, rate and time are inversely proportional. As time goes up, rate goes down. So the slow reaction will give me, a slower rate or a lower rate, and the fast reaction is going to give me a higher rate. Okay, and again, that's because we have to look at our denominator, which is time here. That's going to change the mathematical value of rate. So if I look at my choices A, B, C, D, I can tell that the answer must be B. The reaction time decreases. When that happens, the rate of reaction increases. That's what I showed here. When the reaction time decreased, the reaction rate increased. That's how we look at the relationship between rate and time of a chemical reaction.